Hello, this is Jeff Scott of Rankin Technical College. I've been going over Farrell's Microsoft Visual C# 2015 and Introduction to Object-Oriented Programming. I've gone through the first 8 chapters full of PowerPoints, and along the way I've also written some code, and I'm going to go into Chapter 9 right now. Chapter 9 starts to talk about object orientation. All right, there's been a lot written about object orientation. I might give some examples that you've heard before. I might give some examples that you haven't heard before if you've done any investigatory work on the subject. So let's just get to it. Our specific objectives: we want to learn about classes, we want to learn about objects, we want to learn about properties, talk about the access modifiers, and particularly public and private. Talk about where it says learn about the this reference. The word this is actually a keyword in the C# programming language, as it is in Java. Write and use constructors, use object initializers, overload operators, declare object arrays and use methods with them, write destructors, and understand GUI application objects. Okay, I'm not going to at all disagree with the author, but where she says here a class is a group, I'd say a class is a blueprint. All right, and again, the example that she gives here is just fine. There's absolutely nothing wrong with it. But let's take this into something that would be more, I don't know exactly if this would be in the programming vein or not, but let's go over a couple different examples. First of all, let's say that I create a class that's called bank account. So everybody who comes into a bank to open up an account, regardless of the type of account it is, probably is going to have to give things like their name, their address, their city, their state, their zip, their social security number, a phone number, etc. All right. So I could create a class or a blueprint that was called account, and I could have all those things in it. Then, as you'll see in the next chapter, not in this chapter, but in chapter 10, we can use something that's called inheritance. And I can make what are called subclasses or child classes. So I could say, okay, I've got this thing that's called bank account. So I've made this class called bank account. I already told you the stuff it would have in it. But now I could create a child of that was called checking account, and another one that was called savings account. Much in the same way as the author shows here, you could have a class that was called animal. And underneath animal, you could have a dog class, a cat class, and a cow class. Under the dog class, you could have beagle, Labrador, Great Dane, golden retriever, etc. All right? So classes, as mentioned there, are basically the building blocks of object-oriented programming, where classes represent blueprints. Every time you create something of that class or an example of that class, that's known as an object. In fact, the idea of creating an object from a class is called instancing the class or instantiation. So we've already been using some classes, whether you realize it or not. And as the author mentions here, double, int32, float, etc. are classes. So any number declared as one of these classes can be used for different operations. There's different types of classes. So far, all we've done is we've had a single file that's held all of our code. Okay, and that single file has had a main in it. Okay. Now, what you'll see in this chapter is we'll create not only a file with main in it, but we'll also create another file when we go through a programmatic example in a little bit. And when we do that, what you'll see is you'll have another file that's not part of main. Okay, it'll be just a CS file or a .cs or a C# file. But the thing that's important about it is it won't have any graphical user interface. All right, so I've already introduced you to an object, as the author mentions on the slide here. Every object is a member of a more general class. An object is an instance of a class. Creating an object from a class is called instantiation. okay? Instance variables, also called fields. Well, if you remember earlier, I gave you the example of a bank account, and I said you would come into a bank and you would give things like your first name, last name, address, city, state, zip, social security number, phone number, etc. Those would be instance variables. So each time you created an instance of a bank account, each one of those could have a different name, address, city, state, zip, etc., and probably would. So instance variables, as mentioned on the slide here, they hold the different data of a class that differ for each object that you created in the class. Instance variables they're sometimes called fields. They're sometimes also called attributes. All right? But they're data. The way that you act upon that data, those are known as methods. Sometimes they're called behaviors, but more often they're referred to as methods. Every instance of a class has the same methods. Now, I want to give you another example of this. And again, I'm not sure if this is a good example or maybe not that good, but this is one I've given in the past, so I'm going to just try to share this with you. Imagine that you live across the street from just a real huge farm field. That's 100 acres, okay? And for years, the farmer has grown nothing on it but grass. All right, so a developer comes in and makes an offer to the farmer who sells the land to the developer. And that developer is on those 100 acres of land is going to create 100 houses. All right, each house will occupy an acre. And the developer has 5 different house plans. We'll just call them Plan A, Plan B, Plan C, Plan D, and Plan E. And he's going to go 5 across with a house A, house B, house C, Plan A, Plan B, Plan C, Plan D, and Plan E. Then another row of Plan A, Plan B, Plan C, Plan D, and Plan E 20 times. All right? Each one of those 5 different house plans would be a house plan class. Each one of the 100 houses, 20 from each class, would be an instance or a house object. Now, each one of those houses could conceivably be a different color. Some might have, aluminum siding. All right. Some of them, some of them might be red in color. Some of them might be green in color. Some of them might be blue in color. So each instance of a house, all right, so if we had a field called color, each one could conceivably be different. But the way that the house would work, for example, open door, let's say. All right, or even a better example, let's suppose that all these houses, with all these different house plans, yes, indeed could possibly be different. But if I've got a house from Plan B, doesn't matter what row that house is in, doesn't matter what color it is, it's always going to have 3 bedrooms, it's always going to have 2 baths, and it's going to have a finished basement, let's say. All right, so if I had methods or behaviors that existed for each one of those Plan B houses, they'd be the same. Now, we're going to write in just a little bit a class client. We're going to write a program that's going to create objects of a class. We're going to do that in just a bit. All right, so when you start to work with classes, you have to start talking about things that are referred to as class access modifiers. All right, and again, let's just for a second, let's move away from the idea of computers and let's talk about what's supposed to be real life. Now, what I'm going to tell you, I realize, is not real life, but the way it's supposed to be. If something is public, it's accessible by all. Now, even though I realize I can't do this, in fact, I'd probably get arrested if I tried, but I should, as a tax-paying citizen of the United States of America, I should be able to walk into the White House, talk to whoever's in charge there and say, excuse me, I'd like an appointment with President Obama, please. All right, I just would like to talk about some stuff with him. Now, again, I realize that's not going to happen. All right, that's not the way the world works. But with him being a public figure, technically, he should be accessible to each and every person in the United States of America. So when something is public, it's basically accessible to all. Now, if instead I drive down the street and I park my car in someone's driveway that I don't even know, I walk up to their house and I try the door and it happens to be open, and I walk up by somebody and they go, "What are you doing here? Who are you?" And I say, I tell them who I am, and I just say, "I just want to have a talk." And they're like, "I don't know you. What do you, what's wrong with you, etc." That's private. I don't have any business doing anything like that. So when something is public, it's like a public person. Technically, they're supposed to be accessible to all. When something is private, they're only accessible typically to like friends and family type of thing. And it's the same type of an idea here. So when something is public, it's available, all right? So if I create something in a class that's public, it's available in that class, and it's available to any other class that wants to use it. If I create something that's private, it's available to that class, but only directly to that class. If you remember earlier, I gave you the example and I talked about having a bank account. And then I said from that bank account, we'd create a child class that was called checking account. All right? If I create a variable in a parent class that's protected, that means that it can be changed in the parent class or in any of the child classes. So if I declared a variable inside of a class called bank account that was protected, I could change the value of that variable in a child class. All right, and the other one that's in here is something that's called internal. That's actually what you get by default. And with internal, okay, and here's, maybe I should have turned to this page first, but when something is internal, if I'm creating a project and I don't say public, I don't say private, I don't say protected, and I don't say internal, it defaults to internal. So that means anything that's basically in the project folder that I've created can access this. And that's what they're talking about in here. So you can read that yourselves in Table 9.1. So this is how you create a class. The keyword class, all in lowercase. Again, it's a keyword. The name of your class. Then inside of curly braces, you put any variables for each instance of that class and any methods that all the instances will share in there. So again, when you create a class, you define both its attributes and its methods. All right, there are some words. Some of these we've talked about in here already. Most class fields, as they say right there, are non-static and private because they give the highest level of security. In a nutshell, so I'm going to tell you something that almost always holds true. There are exceptions. But what object-oriented programming is about, in a nutshell, in a sentence, is it's using public methods, all right, to access and possibly modify private data. All right? Public methods to access or modify private data. So in the example right here, we've created a class name employee. And every time I create an instance of that class, each employee will have their own ID number. It's private, so it'll only be available within this class here. It's an integer, and it's called ID number. As they mention here, using private fields within a class is what's known as information hiding. It also pretty much is the definition of encapsulation. It's basically someone else can use that class without having to know how it works internally. So again, private fields, and notice underneath, most class methods are public. Now it is possible for you to have public data, but it's highly discouraged. You should never do that. That means that anyone can change the value of the data, and then you have no control. You can also have private methods. Typically, when you have a private method, it's known as a helper method. All right, so imagine that what I did was I say to somebody, I say to one of my students, okay, so I say, Brady, do me a favor, okay, and I'd like you to go and get me a soda. And Brady's a little surprised, but he said, yeah, okay, I'll do it. And Brady's going to go get me a soda, but he thinks about it, and Eric, who sits across from him, owes Brady a favor. So Brady said, hey, Eric, you owe me a favor. I want you to go, here's $2. I want you to go and get Jeff a soda and bring it back and bring it to me. So I asked Brady to do something. Brady delegated the authority to Eric. Eric did it, came back to Brady, who came back and gave me the result. That's a helper method. That would be a private method because I'm not the wiser unless Brady tells me that he had Eric get me the soda. I don't know that he did it, and probably I don't care as long as I get my soda. That kind of an example. Another term that's mentioned here is composition, and it says using an object within another object. Let's suppose that, you can model anything. And object-oriented programming is, in essence, it's the ultimate in modeling. So let's say that I want to model a clock. So I create a class where here we said class employee. Let's say I could say class clock. And I say private int hours, private int minutes, private int seconds. All right, and I say that you can set hours, set minutes, set seconds, get hours, get minutes, get seconds, etc. Now later, somebody else comes in, and what they like to do is they like to create an alarm clock. They could start all over from scratch, but why should they? So if they include my clock object, if they include my clock class as one of the members of their class, that's what's called composition. All right? Okay, so we're getting a little further here. We have both, when you look right here, an attribute, which is ID number, and we have a method. So notice private attribute, public method. All right, this is the entire class. Okay, as it currently stands, it can't do anything because we have to create an object of the employee class, and then that object can both have an ID number set to it, and we can call the welcome message for it. So, as it says, declaring a class, as we just did, doesn't create any objects. The idea of creating an object is two-pronged. You declare a reference to the object, and then you create it using the new keyword. Now, notice the example I give here. Employee my assistant, and then my assistant equal new employee. It's almost never done like this. Instead, it's almost always done like this in just one line, because there's no reason not to. All right? So let's break this down. Let's look at this statement here. This is a data type. Remember, we created up here class employee. So that is now a data type. So employee, that's the name of the data type. That's the name of the object. Equals new employee. And notice the word employee appears here and appears here. This is a data type. This is a call. Sorry, I have to stop for just a second. All right, I'm taping this in my apartment, and whenever the air conditioner goes on, it's so loud that it's hard to hear me, and you hear a constant hum, and that's why I paused. Okay, so we mentioned that declaring the class itself does not create an object. Okay, you create the object with the new keyword, and again, I mentioned data type, object name equals new data type. And you'll notice on the right-hand side of the equal sign, after the data type, which is a class, you put a set of parentheses. So what we're doing here is we're creating a new object of the employee class that's called my assistant. What that call on the on the right-hand side of the equal sign will do is it will call the class constructor. And what the class constructor is it is a special method that gets called whenever you create an object. It's got the same name as the class itself. If you do not create your own constructor, one gets created for you. So right here, notice what we have. It says here, employee my assistant equals new employee. Okay? And then my assistant.welcome message. Well, what is that? Well, now we're creating a brand new variable object in this case called my assistant. And my assistant can call that method welcome message. Okay, it can call that from here, and that's what happens. So it's going to say, welcome from employee, and even though we haven't initialized that, it'll automatically get initialized to the number 0. So it says there, welcome from employee 0, can I help you? All right. Just like you pass, for example, an integer or a float or a double or a string to a method, you can pass an object to a method. So if we look at this, notice what we have here. We've got, here we're creating one employee object that's called a worker. Here we're creating a second employee object that's called another worker. Then we're calling this display employee data. All right? And we're passing it first, which is some kind of order, and then we're passing it the name of the actual object itself. So when you look at this, it comes in here and it says first employee's message, and that first, that's right there, that's this. And then it says second employee's message. That second is this. So the bottom line is you can go in and you can pass. It is totally legal for you to pass objects to methods, just like you pass any other kind of variable. In addition, you can return an object from a method. All right. So, objects have properties. And notice what it says here. A property is a member of a class that provides access to a field of a class. It defines how fields will be set and retrieved. And if you notice in here, they talk about set accessors and they talk about get accessors. And collectively, the author here refers to them collectively as accessors. Now, that's not always the verbiage that's used in all languages. For example, in the Java programming language, the get, these are called accessors. The set, these are called mutators, or getters and setters, as they're called here. If I have a get and a set for a property, and you're going to see this in the next slide or two, that means I'm able to both set a value for that property and retrieve that value. If I put a get but not a set, that means it's read only. If I put a set and not a get, it means it's write only. So, if we look at this, and this is one way of doing it. This is not the only way, but this is a way of doing it. So notice what we've done here. We've created a variable that's called ID number. And notice please the caseness. The word ID in ID number, they're both lowercase. The N in number is uppercase. But then, so right there, then below it, we've got ID number. We could actually call that anything, but typically you call it, you do it like this. And the get will return the current value of that ID number. And the set will say that whatever value you pass into that ID number, set the ID number to that value. Now, one thing you have to realize, we're doing something that's totally different than we've done in any chapter before. So it's of paramount importance that you read the textbook and really look and study the examples. All right, so we just looked at one way that you can do gets and sets. You can also work with what are called implicit parameters. As it says, an implicit parameter is one that is undeclared and it gets its value automatically. All right, so notice some of these words, get, set, etc. Well, if we look in here, now we're saying here employee, my chef equals new employee. So that's going to call a constructor. Even if we don't have one, then what's called a default constructor, which does nothing, will be called. Once we've got my chef, then we can set the ID number and we can do the welcome message. Notice that previously, every time we set that, we never set the ID number, so it always just came out to 0. Here we're setting it to 2, 3, 4, 5, so you'll notice the message from the DOS command line there that you see towards the upper right hand corner. Now it says ID number equals 2345. Welcome from employee number 2345. How can I help you? All right. So we talked a little bit about properties, and we looked at one way that you can set up properties. Another way that you can set up properties, and the way that's probably used more often, are what are referred to as auto-implemented properties or automatic properties. As it says, the properties implementation is created for you with the assumption that the set should simply assign and the get should simply return. So if you use an auto-implemented property, you don't need to declare the field that corresponds to the property. What does that mean? That means that you can do something like this. So notice we just have public int ID number get set, public double salary get set. Now, that's a good thing in that the amount of code in there is very limited, brief, whatever you want to call it. But it's a bad thing because that assumes that you're not doing any kind of validation, especially if you're doing some kind of a set routine. It supposes that the person who's going to call this routine will always pass in an integer or will always pass in a double. All right? So some people use this and use it religiously. Other people are leery about using it. All right, I do it both ways depending on what it is we're talking about. So again, as we looked at earlier, methods are usually public. Fields are usually private. Data should be as hidden as possible. Again, that's abstraction, and it's encapsulation. And as I mentioned, you can create public data, but you shouldn't. A named constant, so if you use const within a class, it's always static, which means it belongs, if I create a constant for a class, that means it doesn't belong to any instance of the class, it belongs to the class itself. So here's an example of a constant. I don't like this example. I find it very confusing, but you can take a look at it. All right. As I mentioned to you previously, the word this, T-H-I-S, that word is a keyword in both the C# programming language and in the Java programming language. As they mentioned, you might eventually create thousands of objects from a class. So let's say I created a class called person. I may create 1,000 person objects. Okay? Each object does not need to store its own copy of each property and each method if they're going, especially each method because they're going to be the same. If I, you have a method that's called wave, and you want to be able to wave at somebody, it's going to be the same kind of wave method. The only thing that might differ is, do I have the person wave once or twice, or do I have them wave 5 or 6 times type of an idea. As it says, the this reference is what's referred to as an implicitly passed reference. When you call a method, you use it. All right, so here's an example right here. Now this is a little, I shouldn't say this because it sounds like a bad pun, but the example here and the example here are exactly the same. You don't need the word this. Some people would consider it redundant, but it is totally okay to use it. And there's the call for it. All right. Sometimes it is mandatory that you use the word this. Here is an example. Notice we have here, right here, on this line where I'm moving the mouse around, this is a class instance variable called price. And it's called price here, and it's called price there. So notice we say this dot price equal price. And as it says, now because you put this in front of it, that infers that you're talking about this. And the price right there, that infers that you're talking about this. If you had left the this off in that example, and instead of saying this dot price equal price, if you had instead said price equal price, you would actually get an error message. Well, you probably wouldn't get an error message, but what you do is you would copy whatever is in here right to itself. Because if I said price equal price, in both cases, on the left-hand side of the equal sign and on the right-hand side of the equal sign, I'd be referring to that value. So when you have a parameter in a method, and that parameter has the same name as the actual attribute name that it's talking about, then you need the word this. Otherwise, it's optional. All right, we talked a little bit about constructors, but we have not seen them yet in action. As it says, a constructor is a special method that instantiates or creates an object. If you don't create your own constructor, one gets created for you that virtually does nothing. All right? So here's an example of a constructor that's called a parameterless constructor. What do I mean? Well, the class here is named employee, and here this is called employee. And it's parameterless because there are no parens in there. So what this says in English is, if I create a brand new employee, if I do that, that employee will automatically have a pay rate of $9.99. Because when I create a new employee, this is the constructor that would be called right here, and it would set pay rate equal to 9.99. Now, if you want to, you can have several constructors. So let's suppose, this isn't a good, I'm going to just go back to this example, but let's suppose for an employee, let's say that we have a first name, a last name, an hours worked, and an hourly rate. I might have all sorts of different constructors. One when I pass in nothing, one when I pass in the first name and the last name, one when I pass in the first name and the last name and the hours worked only, one with the first name, last name, and the hourly rate only, and maybe one where I pass in all four values. That would be 5 different examples of constructors. So those are referred to as overloaded constructors. So as it says, you can write as many constructors as you want as long as the argument lists, all right, don't cause ambiguity. So notice here I've got a parameterless constructor, one that takes no parameters. Then I've got another constructor that takes an integer. Then I've got another constructor that takes an integer and a double. And I've got another constructor that takes a character. In each one of these constructors, what's in the parentheses, which is also known as the method signature, every time it's different. All right, here's how I would call those particular constructors. All right. You can also use something that's referred to as a constructor initializer. As mentioned right here, it indicates another instance of a class constructor should be executed before any statements in the current body. What does that mean? All right. Well, notice right here, what this is saying is, if I call a constructor, okay? If I call this constructor with nothing in it, automatically end up setting 999 to the employee ID and 0 to the salary. If I call this constructor, whatever employee ID that I added, set that, but set the salary to 0. If I call this constructor, I've already got both of them passed in. So I'm fine. And if I call this constructor, all right, then 111 will be the employee ID and 100,000 will be the salary. Again, this probably won't make a lot of sense until you start to see it in action, and even more so until you start to create your own objects. All right. Making something read-only, as mentioned, is similar to using const. It's assigned a value that can't be changed. But unlike a constant, you can assign the value at runtime, but once it's set, you can't change it. So you can get a value from input, from the operating system, from whatever, from the environment, whatever it happens to be. Now, the author mentions that even though something here is what you put it in, you said read only, here we're trying to change it. And the author says, don't do that. This statement will generate an error. Why? Because you said it's read only and now you're trying to change its value. not only, there's a lot of different ways you can set up initializers. And one way is to use what's called an object initializer. When you do that, you initialize the class when you create it, all right, the object when you create it or instantiate it, and you don't have to call a constructor. So this is saying, create a new employee object, all right, that's called a worker and set the ID to 101. You can do it either one of these ways. All right. Some people like to use object initializers because they find them easier to work with and more intuitive. Other people shy away from them. And if you notice, I'm not giving you my own opinion just because of the fact that everyone's different in the way they code and what makes sense to them and what does not make sense to them. All right, probably the hardest thing so far in this class will be the next section, and that's on overloading operators. When you overload an operator, what you're doing typically is you're trying to use an operator on an object in the same way or a similar way that it would be used by a simple data type. So as mentioned, overloading operators allows you to use arithmetic symbols, but with your own objects. Notice these are overloadable, these are overloadable, these are not overloadable, and you cannot overload an operator for a built-in data type. When a binary operator is overloaded and has a corresponding assignment operator, which would be typically an equal sign, it's also overloaded. Some operators must be overloaded in pairs. So if you overload the double equals, you must also overload the not equals. If you overload the less than, you must overload the greater than. This is the syntax for doing it. You're going to see some examples. Here's an example right here. What we've done right here is we're actually creating new objects. We've got one called a book object called first and one called second. We want to be able to add those two objects together. Oh, my air just went on again, so I have to pause for just a minute. I'm sorry. All right, so let's continue on. In the example that you see right here, again, we are overloading the plus operator, which is allowing us to add object values, and we're overloading the greater than operator. And here's some examples. So we are now able to say the new title is Silas Marner Moby Dick, and we're able to say how many pages it has, which is 350 and 250, which is 600, and the cost, which is $15.95, and it says if the first is greater than the second, and it's not, so we'd hit the else. So the new price is the second price plus 10. So it's 16 plus 10, which is 26. Kind of a convoluted example, probably not one you'd use very often. All right. Here's a unary or operator. So you're saying the price equals the negative price. As mentioned right here, you can declare arrays that hold elements of any type. Even, so if I created an employee object, I could have an array of employee objects. Here I'd have 7, employee 0, employee 1, employee 2, all the way through employee 6. Not only can I create arrays of objects like this, but even when you think about it, even if I wanted to create a whole bunch of buttons on a GUI form, I could put those in an array if I wanted to. All right. Now, C# has some built-in methods for you that work with arrays, and these are nice. The sort method will basically sort your array in ascending order. If you want it in descending order, you first run sort, and then you run what's called the reverse method. All right. A binary search, as it says, you give it a sorted array and a value, and it attempts to match the value in the array. With a binary search, it's called a halving search, Halving. The array must be sorted, and it starts looking, and it says, so if you've got 10 values, it looks and sees what the fifth value is, and it says, okay, is that the value you're looking for? No. Is it greater or less than? It's less than. So I know now values 5 through 10 are eliminated. So if that value is in there, it has to be in values 1 through 4. So I look at value 2 and I say, is that it? And they say no. And you say, is it less than that? Yes. So now it either has to be the first value or it's not in the list that you're looking for. All right. One thing about C#, C# is like most other programming languages, like Visual Basic.net, like Java, like most other programming languages, but unlike a language like C++, where with C# you can only have what's called single inheritance. So if I create a child, if I create a child object that's a child of another class, it can only have one parent. All right? So it only supports single inheritance. But what I can do is I can have multiple what are called interfaces. Now, I don't want to read this to you because you can all read yourselves, but the idea is an interface is a collection of methods. So it's almost like having another class, but you give the method name, but you don't say what it's supposed to do. It's a contract, for lack of better words. And it says that any class that's going to what's called implement this interface must agree that it's going to create these methods. So here's an example of the iComparable interface. And with that one, it allows you to compare a couple values, or in this case, a couple objects. If the first one is less than the second one, it returns a negative value, usually -1. If the two are equal, it returns 0. And if the first is greater than the second, it returns a positive number, usually +1. Here's an example where they're going through and they're using both the sort and the binary search to check and see if a certain employee was found in the array. Now, this is a very simple, almost convoluted example because there are so few in there. But if you wanted to, you could make this and be checking hundreds of employees. All right. So you call a constructor, con, when you create a class. If you want to, when a class goes what's called out of scope, you can call its destructor, which is the same name as the constructor, but it has a tilde before the class name. And typically, when the class is destroyed, when it goes out of scope, the reason that you'd call a destructor is to do what's called cleanup type of things. You might want to close a file if it's open, close a database connection, or whatever. All right? So you can create GUI applications that use objects, just like you can create console apps that create objects, and they give an example here. So again, in this chapter, we went over some class concepts. We learned how to create a class. We learned how to create or instantiate objects of that class. We learned about properties, both auto-implemented and non-auto-implemented properties. We learned about public access modifiers, private access modifiers, protected access modifiers, and internal access modifiers. We learned about the keyword this. We learned how to create constructors and even create overloaded constructors. We talked a little bit about object initializers, I should say. We very quickly looked at how to overload operators. We talked about arrays of objects. And we ended by talking about destructors and a little bit on writing GUI object programs. So that's it for Chapter 9. When we come back with Chapter 10, we're going to talk about inheritance. I've already mentioned that a little bit, but we'll talk about it in more depth and breadth of coverage than we have previously.